OSPF, which stands for Open Shortest Path First, is a routing protocol used in computer networks to help routers dynamically exchange information about the network's topology. OSPF is an interior gateway protocol, IGP, meaning it operates within a single autonomous system and is designed to efficiently route traffic within that autonomous system. Here are some key features and aspects of the OSPF protocol. 1. Link State Routing Protocol. OSPF is a link state routing protocol. This means that routers in the network maintain a database of the network's topology. Each router has a detailed and synchronized view of the entire network, which allows it to make intelligent routing decisions. 2. Dijkstra's shortest path. First algorithm. OSPF uses Dijkstra's algorithm to calculate the shortest path to reach a destination. By considering the cost of each link in the network, OSPF determines the optimal routes to different destinations. 3. Hierarchical design. OSPF supports a hierarchical network design with multiple areas. This design helps in organizing large networks and reduces the complexity of the routing table. Routers within an area have detailed information about that area, but only summary information about other areas. 4. Open standard. OSPF is an open standard, which means that its specifications are publicly available. This allows different vendors to implement OSPF in their networking devices, promoting interoperability in heterogeneous network environments. 5. Scalability. OSPF is designed to scale well with the size and complexity of networks. The use of areas and efficient database synchronization mechanisms helps manage large networks effectively. 6. Support for variable length subnet masking, VLSM. OSPF supports VLSM, which allows for more efficient use of IP addresses by enabling the assignment of subnet masks of different lengths to different subnets. 7. Authentication. OSPF provides authentication mechanisms to ensure the integrity of routing information exchanged between routers. This helps in securing the OSPF routing domain. 8. Fast convergence. OSPF is known for its ability to converge quickly in response to changes in the network, such as link failures. This rapid convergence helps in maintaining network stability and reducing downtime. 9. Protocol types. OSPF supports IPv4 and IPv6, making it suitable for both traditional and modern IP networks. OSPF is widely used in enterprise networks and service provider networks due to its scalability, efficiency, and support for complex topologies. It plays a crucial role in enabling routers to dynamically adapt to changes in network conditions and find optimal paths for data transmission.